All right. Sorry about that, folks. You can just put it right there on the table if you want. That's fine. Thanks. Here we go. So, remember, right, the major topic of this unit, okay, that we're learning, okay, in Algebra 1B is solving systems of equations. Okay, and what is a system of equations? It is more than one equation, okay, that you're trying to solve simultaneously. Okay, so you're trying to find answers that answer all the equations in your system. Okay, the major kinds of systems we're looking at are going to have two linear equations. So that's two equations that are lines if you graph them. Okay, we learned one way to solve so far, and what's the one way that we know right now how to solve a system? What do? Graph, right? We have to graph it. Okay. Today we're going to learn a second method that you can utilize, okay, called substitution. Okay, substitution. And then on Monday and Tuesday, we'll be learning a third method called elimination. And then I think we might learn a fourth using matrices and stuff like that. Okay, we'll see about that. But we definitely are going to do elimination on Monday, Tuesday, and then today substitution. Okay? And then eventually, we're going to just give you a system, and we're going to say solve it using whatever method you want. Okay, and then you'll use some strategy, okay, to help you figure out which method you want to use. Because some methods are better than others. It just depends. Okay? So, let's go through what substitution looks like. Okay? Substitution is a little bit more powerful than graphing, but it also is a little more work intensive as well. Okay? Because graphing, in order for us to find the solution, we kind of have to like see where the two lines intersect. And what if they don't intersect at a nice like grid point on our coordinate plane, right? Well, that's going to be a little bit harder to guess or to figure out what the answer is, right? With substitution, though, well, we'll be able to get any answers, okay? But you can see there's quite a bit of work involved sometimes. Anyway, so let's take a look here at this particular system and this method, okay? So here is our system. Okay, I'm going to zoom in maybe a little bit more there for us to see. That's the system. This equation, x equals y minus 2, and this equation, 2x plus 3y equals 16. Okay? Now, you'll notice here that this first equation is telling us that x is the same thing, right? It's equal to the same thing as y minus 2. Right? So, when I look at my equation right here, I see an x. Right? What is the same as this x right here? What were we just told is the same? Yeah?
Whatever the answer is, y minus 2.
Yeah, y minus 2 is the same as x. So you can see here what it says in the little words. It says, since the first equation was solved for x, right, the first equation here, it's got x by itself, we can replace this x in the second equation with y minus 2. So in other words, we're going to take this y minus 2 right here, and we're going to plug it in for x right there. Okay? We're going to take that y minus 2 and plug it in for x. And you can see the x is replaced with y minus 2 in parentheses. Okay? Now, what variables do we have in this equation now? What's the only variable we have in this equation? Y. Can we solve an equation that has a single variable in it? We can, right? We can solve this. So now we're just going to simplify, right? So we'll distribute the 2 times the y, the 2 times the 2, 2y minus 4. So the plus 3y equals 16. Now we have like terms, right? So 2y plus 3y makes the 5y. And we bring down that minus 4. And then we just solve. Add 4 to both sides. So the minus 4 and the plus 4 cancel. You'll have 20 and then the 5y. Divide both sides by 5. The 5s will cancel. And you get y equals 4. Okay? Once we find that y equals 4, how can we figure out what x is? Well, let's look back up here. X is y minus 2. Well, if we know that y is 4, we can put the 4 in for the y right there. Subtract 2. See right there? Put the 4 in for the y. Subtract 2. 4 minus 2 is 2. And there's our final answer, 2, 4. X coordinate 2, y coordinate 4. That's the solution. Okay? So in other words, if you graphed these, if you solve them for y and graph them in your graphing calculator, right, or if you graph them on a piece of paper, you would get the intersection point to be 2, 4. Okay, that's our answer. Okay? So, yeah, question, please.
George, previous one, you said you went from x equals y minus 2 to 2x plus 3 equals 16.
X equals y minus 2 to 2y plus 3 equals 16. So right here,
Yeah.
this is our system. X equals y minus 2 and 2x plus 3y equals 16. That's the system of equations that we're trying to solve. And we plugged into here. Okay? So let's see. Oh, go ahead.
We plugged y minus 2 into 2x.
We plugged y minus 2 in for the x, leaving the 2 there in front. Because we're saying x is y minus 2. So we replace them.
Right, thank you.
Yep, no problem. Okay? So now, the problem though, right? So what if we run across, here's another system right here. Okay? Here's another system right here. None of these are solved for a variable, right? None of these are solved for y or solved for x. So we have to solve for x or solve for y here. Okay? Now, which one of these variables looks like it might be the easiest to solve for? Should we solve for the x here in the first equation or the y in the first equation? So we solve for the 2 in the second equation? Sorry, the x in the second equation or the y in the second equation? Which one of these does it look like is going to be easiest to solve for? What's that? What do you think? So the problem or the directions here suggest that since the y has no coefficient, since this y has no coefficient except for a -1, you should start by isolating this one. Okay, these other variables have have coefficients in front of them, so typically you don't want to isolate those, although you could. But let's isolate this one since it doesn't have a coefficient. Okay, much easier. And so again, you would just take that 3x minus y equals 11, subtract 3x from both sides, divide everything by -1, and you get y equals -11 plus 3x. Okay, and so we rewrite that first equation to this, and then we substitute it into this equation. Okay, and which variable in the second equation are we going to plug this into? Which variable from here does this one get plugged into? Which variable should we plug it into? The y, because it's y equals -11 plus 3x. So we'll just say that's going to go right in there for the y. And you can see that's what they did right here. You can see there's the 2x, there's the 2, and then instead of y, they wrote the -11 plus 3x equals 2 right there. Okay? Whoops, I meant to circle the whole thing there. There we go. Okay? So that's the main idea. Let's try one or two here. Okay, so let's look at number, well, it says to finish number 5. Okay, 5 says to finish the example above. So let's go ahead and do that. Okay, so again, we'll take this one right here, 2x plus 2, and then we'll have the -11 plus 3x equals 2. Okay, yeah, we're going to distribute, exactly right, to simplify. So the 2 times that, the 2 times that. So we get -22, and then 2 times 3 is 6x, like that. Okay, Scott? Yeah, go ahead. Okay. How should we continue to simplify here? What's going to be our next step? Okay, 2x will add with the what? Yeah, well, it's actually it's the positive. Sorry, it's my handwriting. It's a 6x there. I'll zoom in some. There we go. Yeah, combine like terms. You got it. 2 and 6 make 8x plus that -22 equals 2. Okay, well, we want to get the x by itself. So what's with the x we want to get rid of? Well, we got the 8. We also have this -22. So what should we get rid of next? Add 22 to both sides. Add 22 to both sides. Right? We get 8x equals 2 plus 22 is 24. And then, yeah, get the 8 away by dividing it. So we get x equals 3. Oops, I'm off the screen. Let me zoom out some more. There you go. Okay? Are we done? We have the x. We still have to find the y. You got it, the y. Okay? So I would suggest, so you can figure out, you can find the y by plugging the 3 in for the, oops, I got to zoom out some more, sorry. Crikey. Okay. You can find the y's by plugging 3 in for the x here or here, but I'm going to suggest we plug the x in over here because we've got y equals negative 11 plus 3x. So let's just plug the 3 in for that. So we'll have y equals negative 11 plus 3 times 3, like that. This one right here. Okay? So, yep, so y equals negative 11 plus 9. And what is negative 11 plus 9? It's negative 2. And so we get the point. 3, negative 2 is our answer there. Okay? 3, negative 2. Questions on any of that? Let's try another one because this is pretty intense. Okay, let's try the next one here. Okay? So this one. Number 6. Is number 6, that system, is it ready to substitute right off the bat? It is. How can we tell? We have y equals. We have a variable y by itself here. So we have it solved for y in the top. Okay? So y is the same as x minus 2 in this problem. So this x minus 2 right here, we're going to plug it in right there for that y. So we're going to write x plus parentheses x minus 2 equals 12. Okay? Substitution. Okay? How do we simplify from here? What's our next step? Okay? The number in front here, there is a number, we can call it like a 1. And so it's just going to be this, x plus x minus 2 equals 12. Okay? So yeah, what can we do now? What's our next step now? Add the x's. X plus x makes 2x. Don't forget the minus 2 there as well, equals 12. Okay? Now, how do you keep solving? What do we got to do next? Add 2 to both sides. So you get 14. Oops, I forgot to put the plus 2 and the plus 2 there. Okay, so that's gone. And then Jackson, what are we going to do now for our next step? Divide both sides by 2. You got it, sir. Yes. X equals 7. Are we done? No, I know. Gosh, we did all that work. We got an X answer, but we still have to find the Y. That's right. And again, plug it into this one because it's y equals x minus 2. Just plug the 7 in for the x right there. It's going to give you the answer real quick. So put the 7 in the parentheses there. So again, I'm using the equation y equals x minus 2. And then we just figured out that x is 7. Replace it.
Thank you.
So that gives us 5. Are we done now? Pretty much. We just got to write the coordinate. And now we're finished. That is the final answer, 7, 5. That would be the intersection point. So again, if we graphed these two things, if we graphed them, that would be the point of intersection, 7, 5.
You said you posted these Classroom, right?
Google Classroom. Yep. I'll post this to, like the video to Google Classroom. Okay, yeah, we can do that. Okay. All right, so far so good? Questions, anything so far? All right, let's try another one here, then let's look at number 7. Now, number 7, I think there's a typo in number 7. Okay, I think there's a typo. No, not no solution. It's a typo, though. What's the typo here? You guys pick it out?
6S.
Yeah, the S. The S does not belong, right? Which one of these is not like the other, you know, kind of thing. I think the S is not supposed to be there. Yeah. So I would say let's make it 6B, like Eric suggested. I think it's a good idea. Okay? 6B. Okay? So we'll say 2A plus 3B equals 0. A plus 5 equals 6B. Okay? Is this system ready for substitution? No. Why not? We don't have a variable by itself, right? We haven't solved for one of our variables. Now, let's use some strategy up here, okay? Which one is going to be the easiest to solve for? The second equation, the A or the B? B is pretty easy to solve for. You divide everything by 6, but I'm looking ahead here. I'm going to divide 1 by 6. I'm going to divide 5 by 6, and that's going to give me some fractions. And I mean, yeah, I can write fractions if I really want to, but
Subtract 5.
yeah, if I solve for A, all I got to do here is subtract 5, and there's no fractions then. It makes it a little bit easier, right? So let's just do that. Subtract 5 from both sides, get the A by itself. Okay, subtract 5 here, subtract 5 here. So we get A equals 6B minus 5. Okay. And so now, substitute this, right? This is going to substitute right into here for that A. That A, right, is the same thing. These A's are the same. So now I'm going to write 2 parentheses, not A anymore, 6B minus 5, because that is the same as A, plus 3B equals 0. Okay. Oh, it hurts. Okay. So yeah, what's our next step then? Distribute. You got it. 2's in front of parentheses. Distribute the 2. 12b minus 10 plus 3b equals 0. Okay, yep, we got some like terms. Got it, Trey. What are our like terms here, Trey? 12b and 3b, that makes 15b minus 10 equals 0. Okay, now what do we do? Add 10. And then divide by 15. Okay, so b equal 10 divided by 15. If I type that in my calculator, okay, 10 divided by 15. Ugh. Can I just put 0.6 as my answer? Yeah, you can keep 10/15ths if you want to. What's that? 2/3. Yeah, is that what you're going to say, Sky? 2/3. Yeah. How do we know it's 2/3? Well, if you're not comfortable with fractions and simplifying, okay, you can hit the math button. The math button is right below the alpha key. Okay, hit the math button. You'll see this right here, this arrow fraction. It's going to take that decimal answer and convert it to a fraction for us, simplified, and there it is. There's our 2/3. Okay, so you can use that to help you there. 2/3 is your B.
So we solved for A and we solved for A.
Right. And so now we're going to take this B that we've now finally solved for that, and it's a fraction, plug it in. I'm going to plug it into this one right here because it's A equals 6B minus 5. So I've got the B and it's in terms of A, so it's going to be really easy. So 6 times 2/3 minus 5. Okay? So you guys know what 6 times 2/3 is? It is. It's 4. Yeah, very good if you got that. Okay, nice. So 4 minus 5 is -1. So we get A equals -1. And so our answer is, now, these aren't X and Y coordinates. So which one's supposed to go first here? The B or the A? A. Why do you say that? Yeah, alphabetical order, folks. Think alphabetically. Okay, X comes first if it's X's and Y's. A comes first for A's and B's. Okay, so -1 comes 2/3 for the answer. Okay, questions on any of that? All right, I want you to try number 9. Try number 9. Okay, give that one a try. Okay, give that one a try. Okay, I'll give you a hint here. Okay, is number 9 ready for substitution the way it's currently written? Is it ready to substitute right now? Not yet. What do we need to do? It's not ready for substitution. What do we have to do?
Add a line.
Solve for, not add a line, solve for what? X or Y. In this particular case, what's going to be the easiest one to solve for here? Which one of these variables? The x here, the y, the x on top, the y on top, the x on the bottom, the y on the bottom. Which one's going to be easiest to solve for?
Solid trick question. What do you think?
Yeah, solve for the x by adding 2y to both sides, and you got boom. There you go. X equals. Yeah, good job. So go ahead, folks. Give it a try. Okay, we'll come around and help.
All right, come on, let me see you start.
Another question?
The first step. Let me at least see
Do we have a no name or something like that?
Yes, miss.
So that's okay. Oh no, go ahead. That's fine.
Now you know what x is.
For now, and then as it has been.
So now we write it as 3 times what x is. Use parentheses. Come on, Lucy, break.
Okay. So go ahead. Try number 9. Okay. Try number 9, folks. Try number 9. Okay.
Well, is number 9
When
there?
you add
So now, Dawson gave us a hint by saying, hey, we add to y.
Sorry. Put it up there.
We get x by itself. Showing you
X equals -1 plus 2y.
this equation, adding 2y.
Oh, okay. I thought you said something.
Where would you add 2y? Which side?
Right. So
add
then,
2y
you have
here.
x is this.
You do one side, you gotta do the
There's an
other.
x right there.
So that's
Plug
your
it in.
first step.
See what I'm saying? And then solve.
I'm taking 2y. What happens when you add
3 parentheses,
How do I rewrite that?
-1 plus 2y, close parentheses, plus 2y equals 8.
Is x equals -1 plus 2y?
You're replacing it. The x gets replaced because x is this. So you replace the x, substitute in -1 plus 2y, and place the x. Plugs in.
So you want me to put these?
Okay, yes.
You're starting to fade away. 2y minus 1,
Okay.
right? Okay, now do I have x
So-
by itself?
Your two equations.
Now can I take what x is,
Solve
plug it into where x is?
So,
Alright, it says 3 times x. So let's rewrite this. 3 parentheses. What x equals? Parentheses. What is x equal to?
yes.
2y minus 1. No. Do not forget the last variation. What else is there? Plus 2y.
Now, x is the same. X is the same as -1 plus 2y.
Now, I have parentheses and I have a number outside. What am I going to do?
Take this.
Distribute it. Go.
Plug it into the
Oh, yeah. I like the steps. Now show the execution. Olivia. Yes, Olivia.
Whoa.
So now you have x by itself.
Whoa.
Now I want you to solve what x is in this equation you did not solve. Solve for this, plug it into there. Start by rewriting it. What is x? -1 plus 2y. Got it. Love it. Now what else is in there?
More?
Don't forget that. Plus 2y is equal to. What's my next step? Good. Show me. Trey, you finished already? Yeah. Where's your sheet? So what are you gonna do? Use mental telepathy to pick it up? Come on now. Don't care.
I can't.
I got a headache too, but I'm still here.
My body hurts.
Good. Questions? Feeling good? Lauren, did you finish? Why are you giving it? Come on.
Yeah, that's what that braiding.
Hold on a second. I told Grayson he could use it.
He's gone. He went. Yeah, I said that.
All right, give him a chance to get back. Let's not have everybody out at once. And it looks better when I have these things done. How we doing? You need a question, I'll help. Okay, so you said I'm going to add 2y. You heard my buddy over there, Dawson, right? I like it. What happens to -2x or
You said you're gonna add these? I did.
2y plus 2y?
You gotta obey it. You gotta plus y. Plus 2 minus.
Then that one cancels out. -2y plus 2y. It doesn't matter why what. Whatever it's divided by 2, whatever it's divided by 2.
No, you're wrong. I know you're right.
But you're left with x plus 2y plus 1. what you did, Ethan. It looks good. Hold on a second. Like the negative 3, 6y, 8y, added 3. Okay, so the question becomes, did he say can I use it as a fraction? He said, yeah. But, I think you're right. Yeah. But you can leave it as a fraction. And look at that, Ethan.
I'm not done
1
yet.
over 8.
You can. Now, the only problem is that without a calculator, it makes it a little bit more hard. Do you not have a calculator? Okay. Do you have one of those?
Read the wire.
No, I don't.
I have a spare one here. Let me see.
Well, do you have a slip?
Yes, like a red one.
I think it'd be good idea to.
Is it almost done?
Renting one? Definitely. I bought my daughter.
No. Are you 9th grade even?
Look, X equals H2 y. You're gonna need it now. It's probably gonna need it in geometry. X equals 2y. You can plug it in, so you inexpensively used and stuff like that.
Yeah, I don't
Want
want
to
to
rent?
rent.
If you want to rent one, this gives you for the whole year, but you gotta get the calculator. Take the two, talk it over with mom.
Whoa. Eric, you doing okay?
I'm gonna tell you this right now.
Yeah, it is. May I look out of here real quick with you? So, your substitution is perfect. So you want to distribute.
That's why you get the calculator, whether you buy it or rent,
equals 18.
get it. And if you want to have it talk to mom and dad, you're not email or anything like that.
You solve it?
It didn't sound confident.
I didn't get a final formula.
You guys like one more minute here?
Well, you solved 1, so what do? Plug it back in to any one of them to figure out where y is.
Okay, now we're doing it.
Be careful.
This is way harder.
2 parentheses.
All right, so hold on a second. Oh, yeah.
Open it.
We added 2y, so then we have, so we be careful. X is equal to 1. X is equal to
That's what we're going to sub in.
2y minus 1. What's 2y minus plus 2y is 1 x by itself. 2y plus 1. When you plug it back in, you plug in that 2y minus 1 in that cell. Let's plug it back in there. 3 times 2y minus 1 plus 2y is equal to 18.
21 divided by 2.
Now
And I can see where you were distributing. And I had 6y minus 3. Then I went from my like terms.
I think so, yes.
Grayson.
Oh, we got 2 of them right
Do
now.
football next year. What? Do football. You do football next year?
You guys doing okay back here?
We're done.
Big.
Alright, folks.
I like it.
Are we ready to go over things?
I like it. Good answer.
Okay, let's take a look then.
Proper fraction, you can do
got
like
it.
that if you need to.
So, number 9 is a bit nasty because you get some fractions. Alright, but we're going to run into fractions, and so that's why we got to be okay with doing them. Alright? It's going to happen. So, I suggested, right, that you take this first equation here and you solve it for x. We have x minus 2y equals negative 1. Add 2y to both sides so that we have x by itself. Okay? Now that we have x is equal to this, we can take that negative 1 plus 2y and plug it in for the x right there. Okay? So I'll have, I'm going to do it right over here, 3 parentheses, negative 1 plus 2y plus 2y equals 18. Okay? So again, I just substitute it in, negative 1 plus 2y in for the x. Now what should we do to simplify here? Distribute. Okay? So we get negative 3 plus 6y plus 2y equals 18. Combine like terms. So 6 and 2 make 8. Okay? Not divide yet. What's our next step? Add 3 to both sides. We get 8y equals 21. And then divide both sides by 8. Got it. Y equals 21/8. Ugh. But that's it. That's right. Okay. if y is 21/8, now I got to figure out what the x is. What do we do with this now? Substitute it in. I can plug it right back into this equation right here. There's y. I'll replace it with the 21/8. So x equals -1 plus 2 times 21/8. Okay, you can type this whole mess in your calculator if you want to. All right, and if you do that, you're going to get 17/4. Okay, as a fraction. So our final answer then is 17/4, comma 21/8. Okay. Questions on any of that? All good? All right. So, it is. This one was a tricky one with all those fractions and stuff. I got one more paper here for you today. We're not going to do all these problems. All right, I'm not going to give you all these problems. But there are two that I want to look at first. Pass it down, please. There are two that I want to look at first together, and then I'm going to give you a few to do on your own. Okay?
I get a drink before we start.
I don't need to keep it seriously. I want you to ask. That's great. Yeah, this won't, not all of it though, okay? I'm not going to give you all these for homework or anything like that. I'm going to do two together, the two special cases, and then I'll assign a couple problems to you, okay?
Our attention is up on serving.
Oh, I'm sorry.
No, you're fine. Thank you.
Mm-hmm. Okay, we're going to do these two together, and then I'll give you guys your assignment, okay? And again, it's not going to be all these, I promise you. I won't do that to you, okay? But let's take a look here at A and B, okay? Special cases, right? We've seen what kind of special cases we ran into with graphing, right? When we had those parallel lines, that was the special case when we had how many solutions?
If the lines are parallel, but they cross at a different y-intercept, how many times are they going to cross?
If they're parallel, do they ever intersect? No, so no solutions. Okay, we also have the special case where they're the same line. If they're the same line, then Sierra, if they're the same line, we say that they have how many solutions? Infinitely many, because they intersect all over the place, okay? So let's take a look at how that shows up with substitution. Okay, let's specifically look at letter A. Is letter A ready for substitution right away? Yes, we have y equals x plus 2. We can replace the y there. So I'm going to do that real quick. 6x minus 2 parentheses x plus 2 equals -4. Okay? All right. One more. Oh, I'm sorry. Thank you. Y'all. Sorry. No, I'm sorry. I want to make sure I give out the right number of papers there. Okay. Ooh, and actually, I'm sorry. I want to make sure I do something right. There's a typo in this one too. There should be a 3. My apologies if you were working ahead. I'm sorry. 3. Put a 3 there. Make it 3x plus 2. Sorry about that. I realized there was a typo in that one too. Okay. Number 1 is just supposed to be 2. I'll tell you that much. 1 is just supposed to be 2. Okay. Sorry about that, folks. Sorry if you were moving on. I apologize. I really do. 3x plus 2. Sorry. Okay. So we plug in for the y, 3x plus 2. And now we'll distribute like we've been doing. So it's 6x minus 6x minus 4 equals -4. Okay. Now what should we do? Y-like terms. So 6x take away 6x is what? 0. They cancel. So what's left on this left-hand side? -4, and it equals -4. Whoa.
Is that true?
Yeah, that's true.
That is, no, there's no more variables. They're gone. But is -4 equal to -4?
Yes.
Mr. Bryce said. Yes, that's always true. So, This is one of our special cases. We ran across something where it's always going to be true. So do you think this is an infinitely many solution, or is it no solution?
It's infinite.
This one is infinite. This is the infinite because we result in a true statement. Okay? These two lines, these two equations are exactly the same. If you solve this top one for y, you will get 3x plus 2. Okay? They're the exact same. So this is infinitely many solutions. Okay? So true, always true. So infinite solutions. Okay? We end up with an equation that's always true. So it's infinite solutions. Okay, now let's try this next one. Is the next one ready for substitution? No. So let's pick a variable to solve for. Let's solve this bottom equation maybe for x, right? We'll just subtract y from both sides, make it easy on ourselves. So I'll subtract y, and I get x equals -2 minus y. So I just took this equation, solved it for x. Now I'm going to take this and plug it in for the x right there. Sub it in. 2 parentheses, -2 minus y, plus 2y equals 8. Okay, distribute. -4 minus 2y plus 2y equals 8. What's going to happen here? Y's are going to cancel. Variables cancel again. We get -4 equals 8. What? We could add 4 to both sides. Sure, if you wanted to. If I add 4 to both sides, it's still weird.
Yeah. So it's no
Right? I
solution.
get -4 equals 8. I get 0 equals 12. Is that ever true?
No.
No. So which one of the special cases is this? No solution, because it results in this weird, impossible situation. So no solution. Okay. These, what kind of lines would these be if we graph them? Parallel. Parallel. They would never intersect. Okay. So we can right away say these lines must be parallel because there's no solution to this system. These two lines up here for letter A, they must be the exact same line because we have infinite solutions. Okay? Questions on any of this? All right, so for the remaining time in class, I'm going to give you guys some problems to work on here. Okay, you ready for this? I'm going to give you number 4. Number 4, number 2. Okay, so I'll give you a nice and easy number 2 there. It's already ready to go. You already know what x is. All right, and I'm also going to have you do number 12 on the back. Okay, so literally 3 problems. 2, 4, and 12. This will be homework if you don't finish it. But you have 3 problems to
And
Mm-hmm.
you
do in
have 3 adults
10
in here
minutes.
and 1 superstar student to help you out.
That's right.
Let me see it.
That's right.
You can't claim it unless you got evidence to back it up. I know Kurt's grades.
Okay, so again, you're just doing 2, 4, and 12. Okay? 2, 4, and 12. And we will come around and help if you get stuck on something.
And solve for y. Plug it in and solve for y. You need confirmation that you're doing the right thing. You don't. This side. It's not no solution. You got y is equal to. Okay, now tell me what x is if y is 0. So what will y be? Is it the statement? 0. Yeah, okay. Got it. That was kind of easy, wasn't it? You did do it correctly. You did that correctly. Now, you can subtract. You have an infinite subtract. It's y plus 2.